Welcome to Hired in IT. Our mission is simple: help you build the skills that employers actually want. Whether you're trying to land your first IT job, switch careers, earn a promotion, or increase your salary, we're here to help. Every video is thoroughly researched and designed to make complex IT topics easy to understand. If there's an IT topic you'd like us to cover, leave a comment below. We may turn your suggestion into our next video. Turning IT knowledge into career opportunities. A developer spent days staring at a login button that just wouldn't work. Not because the button was broken, because he couldn't get his front end, his database, and his auth provider to agree on who was signed in. He was learning Next.js, the React framework that powers both front-end and back-end. Clerk, a service for handling user authentication. Convex, a real-time back-end database. And Tailwind, the utility-first CSS framework that styles your UI without custom CSS. But he was learning them in isolation. In the last 3 parts of this Claude masterclass, we installed Claude Code, mastered the CLI, and set up Git. Now we're flipping the script. We're building a full-stack app that would normally take weeks in a single video. The real skill isn't any one technology, it's making the whole stack talk to each other. And Claude Code eliminates the glue work that kills most projects. By the time this video ends, you'll walk away with 3 concrete skills: scaffolding a full production stack with Next.js, Convex, Clerk, and Stripe in one go using Claude Code. Making authentication and the database actually cooperate so sign-in works the first time. And deploying the whole thing to Vercel with secrets in place. No broken builds, no leaked credentials. Here's the truth. Most tutorials skip. Full stack isn't a stack, it's a contract. You don't just write code for the front end, back end, and database. You own the communication between them. That's where most projects break. A user opens your application, Clerk verifies who they are, Next.js serves the interface and routes requests, Convex stores and retrieves data, Stripe processes payments, and your AI service performs the translation. Every component depends on the others working together. That's why companies value engineers who understand complete systems rather than isolated technologies. Industry salary surveys consistently place experienced full-stack engineers among the better-paid software professionals because they're able to design, build, and maintain production-ready applications from end to end. Once you understand this contract, you'll spend less time debugging individual tools and more time delivering working software. Building a production application isn't about memorizing frameworks. It's about learning how complete systems work together. Modern companies value engineers who can connect authentication, databases, APIs, AI services, payments, and deployment into a single reliable application. That's exactly what you'll build throughout this project. As we move through each section, don't worry if every framework feels unfamiliar. Claude Code can generate much of the boilerplate and repetitive configuration for you. Your job is to understand why each technology exists, how the pieces communicate, and how to troubleshoot the system when something doesn't work. That's the mindset that turns someone who can write code into someone who can ship production software. Why invest time learning this stack? Because modern companies increasingly hire developers who can deliver complete features instead of isolated pieces of an application. Rather than specializing in only front-end or back-end development, full-stack engineers understand how the entire system works together, from the user interface to authentication, databases, payments, deployment, and AI integration. Throughout this project, we'll use 8 core technologies: Next.js for the application framework, React for the user interface, Tailwind CSS for styling, Clerk for authentication, Convex for the backend and database, Stripe for payments, Vercel for deployment, and Claude Code as our AI development assistant. Don't worry if some of these tools are new. The goal isn't to master every product today. It's to understand how they work together to build production-ready applications. Quick recall. What are the 8 tools that make up our production stack, and what does each one do? Before writing any code, verify that your development environment is ready. Check that your installed version of Node.js meets the current requirements listed in the official Claude Code documentation, confirm that your API key is configured correctly, and verify your Claude Code installation by running Claude version. If any of these checks fail, it's much easier to solve them now than halfway through building your application. You first learned this workflow in the installation lesson. Today, we're simply confirming that everything is ready before we start developing. Scaffolding a Next.js project starts with Create Next App. Run the command, answer the interactive prompts to include TypeScript, Tailwind, and the app router, and Next.js generates the project structure. The output shows the app folder, where all your routes, layouts, and API endpoints will live. The app router is the modern approach, so make sure you include it. The app router isn't just a rename of pages. It rethinks how you build full-stack apps. Server components let you render on the server without shipping client JavaScript for every component. Layouts let you wrap entire sections with shared UI, like a sidebar, without duplicating code. And an API folder inside the app directory means your front-end routes and API endpoints live right next to each other. The old Pages router splits pages and APIs across separate directories, creating the exact glue code we're trying to eliminate. So when you scaffold with the app flag, you're already ahead. Here's what actually happens when a user hits your app. The request first flows through layout.tsx, which wraps every page with your navigation and global styles. Then page.tsx renders the specific route. If the page needs data, it calls an API route inside the API folder. That's just a serverless function living next to your UI. That API route talks to Convex, and Convex returns data. This is the app router's superpower. Everything lives in one directory, so your data fetching logic sits right next to the page it serves. No separate server project, no confusing separation, just the same contract we drew earlier. Before we write more code, take a quick look at the project layout. The app folder contains your pages, layouts, and API routes. The Components folder holds reusable user interface elements. The Convex folder contains your backend functions, schema, and authentication configuration. The public folder stores static assets, while utility code typically lives in folders such as lib. Knowing where code belongs makes it much easier to understand projects generated by Claude Code and keeps your application organized as it grows. You'll install the integration packages, the Clerk SDK for authentication, Convex for backend, and Stripe for payments. Claude Code will suggest these, but understanding the command yourself means you know what goes into the stack, not just copy-pasting. Later, you'll configure a JWT template so Clerk can issue tokens for Convex. For now, get the SDKs installed. Quick recall. You just ran a single npm install command that added 3 new SDKs to your project. What are those 3 packages, and what does each one do? Before we go further, a quick definition. JWT stands for JSON Web Token. It's a secure, compact way to transmit user identity between Clerk and Convex, essentially a digitally signed proof that you are who you say you are. Now, 2 rules that prevent your entire app from being compromised. A single secret key on GitHub lets anyone impersonate your users. This is the #1 credential leak vector in full-stack projects. Secret keys stay in .env local and are never committed. Next.js only exposes environment variables to the browser if they start with next public songs. Before we connect Clerk and Convex, don't worry if these configuration files look unfamiliar. Claude Code can generate much of this setup for you, but understanding what the configuration does is what turns you into a full-stack engineer. Convex needs to know which identity provider it should trust for JSON Web Tokens. The convex auth.config.ts file defines that relationship. The issuer URL must exactly match the value from your Clerk JWT template. If those values don't match, Convex rejects every authenticated request, even though your application may appear to load normally. Understanding this trust relationship is much more important than memorizing the file itself. Here's the JWT journey. User clicks login, Clerk issues a JWT, Next.js passes it to Convex, Convex validates it against Clerk's published keys, and only then does the database query run with the real user identity. The 2 hops that break silently if the issuer URL is off. Next.js, sending the JWT and Convex validating it. Let's make sure the authentication flow is clear. Before Convex allows a query to run, what must happen first? Take a moment to think about it. The answer is that Clerk must issue a valid JSON Web Token. Next.js passes that token to Convex, and Convex verifies it against Clerk before executing the request. If any part of that chain fails, especially the issuer URL, authentication silently breaks. Understanding that handshake is far more important than memorizing configuration files. Once your auth config is deployed, you can verify it's live in the Convex dashboard. Under Functions, you'll see your schema, the user's table, and any other documents you've defined. This is your proof that the configuration was accepted and Convex is ready to accept authenticated requests. One wrong issuer URL and your users see nothing but a blank screen. No error message, no loading spinner, just silence. That's the silent killer in every Clerk Convex integration, and Claude Code won't warn you unless you know exactly what question to ask. Let's fix that right now so you never stare at a dead app again. This is another step where Claude Code can generate most of the configuration for you, but it's still important to understand what it's doing. In convex auth.config.ts, set the issuer field to the exact issuer URL from your Clerk JWT template, not your general Clerk domain. If the configuration still contains a placeholder such as provide, the authentication handshake hasn't been completed. Once the correct issuer is in place and the configuration is deployed, Clerk and Convex can trust each other and authenticated requests will begin working normally. To prove the auth is wired, write a quick query that returns the current user's identity. ctx.auth.getUserIdentity fetches the Clerk user data from the JWT. If this function returns a valid identity, you've nailed the Clerk Convex handshake. If not, the JWT is either missing or invalid. Back to the issuer URL. Once it works, run npx convex deploy to push your schema live. Here are the 3 traps that silently break Clerk Convex auth every time. First, if your issuer URL still contains provide, you haven't finished the JWT template setup. Second, if the domain in convex auth.config.ts doesn't exactly match the issuer domain from Clerk, Convex rejects every token. Third, after you fix the config, you must run npx convex deploy. Otherwise, the old broken config remains in production. Quick checkpoint. In Convex, how do you pull the current user's identity inside a query or mutation? Answers in 3, 2, cttext, auth.getUserIdentity. If you had to read the hint, that's okay. That's the one method that prevents silent auth failures. Everything we've configured so far has been preparing us for a real application. Instead of building another to-do list or sample dashboard, we're creating a production-style PDF translation service. A user uploads a document, securely signs in, completes payment, the translation runs on the server using AI, and the translated document becomes available for download. Along the way, you'll see how authentication, databases, AI services, payments, and deployment work together as one integrated system. Focus on understanding how each component contributes to the overall workflow rather than trying to memorize every implementation detail. Here's the exact user journey. A customer drags a PDF onto the upload zone, picks source and target languages, then hits Stripe checkout. A real payment, not a mock-up. After payment, a Convex action fires off a call to OpenAI's translation model, processes the document, stores the translated PDF in Convex file storage, and generates a secure download link. No server management, no cron jobs, no IAM headache. Just a clean full-stack flow that Claude Code can wire together in a single session. Give Claude Code this prompt. Generate a React component with Tailwind that uses React dropzone for PDF upload. On drop, call a Convex file upload mutation. Add a loading bar and error state. It returns a clean 30-line component. The highlighted line is where the drop event fires a Convex mutation. No REST API, no fetch. Just an imported function that pushes the file directly to your database. That glue code you spent 3 weeks debugging? Gone. This is the Convex mutation that persists an uploaded file. The highlighted line returns a direct URL to the stored PDF. No S3 pre-signed URL gymnastics, no bucket policy configuration. Convex owns the storage, and the getURL method gives you a permanent authenticated link. Later, when the translation action finishes, we'll point the user right back to this URL. Full-stack file management in 4 lines of backend code. Now test it live. On localhost dar3000, click the upload zone and pick a sample PDF. A 1-page contract works fine. The moment you drop it, a progress bar pulses, and then a success message shows a unique file ID. Copy that ID and jump into your Convex dashboard. Under the Files tab, you'll see the same PDF sitting in Manage Storage, no configuration required. When you can confirm that ID exists in the dashboard, you've wired file upload end-to-end. Let's make sure the upload process is clear. When a user drops a PDF onto the upload area, what actually happens? Take a moment to think about it. The file is uploaded through the React dropzone interface, which calls a Convex file upload mutation. Convex stores the file, returns a unique file ID, and that ID becomes the reference used throughout the rest of the application, from translation to generating the final download link. Understanding that workflow is much more important than memorizing the implementation details. If you put your OpenAI API key in a React component, anyone who opens DevTools can copy it and drain your account in minutes. That's why translation runs on the server. Our Convex action will call OpenAI inside a secure backend environment where process.envote.openai API. Key lives in convex environment variables, never in front-end code. The browser sends the request, the action does the heavy compute, and the result flows back to the user. That separation. Client for UI, server for secrets and expensive operations is the full-stack contract that keeps your app secure and your build predictable. This convex action reads the uploaded file and triggers a translation, using a secure back-end environment where API keys never touch the front end. The implementation details depend on your provider, but the pattern is the same. Environment variables for secrets, server-side logic for data processing. Your OpenAI API key belongs in exactly two spots: convex environment variables, set via the CLI, and vercel environment variables, added in the project dashboard. Never in code. Even if you remove the key before pushing, the commit history remembers it. One leaked key, and anyone can burn your AI credits or impersonate your users. Use the convex CLI to set it, and vercel to inject it. That's the only path. This API route sits at app API translate route.ts. It receives a post with the convex file ID and language pair. The route is protected by Clerk middleware. If the user isn't signed in, the request never reaches this code. Inside, we call the convex translation action we built earlier, passing the file ID and languages. Because the Clerk Convex handshake is already wired, the Convex client automatically inherits the user's JWT, so authentication is seamless. This is the glue that ties the front-end button press to the server-side AI call. In the browser, our PDF translator is live. I pick Spanish as the source and English as the target. Hit translate. The button morphs into a loading spinner while the convex action fires up the AI model in the cloud. A few seconds later, the translated English text replaces the spinner. No console errors, no CORS complaints, no blank screens. That's what a properly wired full-stack app looks like. Quick knowledge check. Where should your OpenAI API key live? Take a moment to think about it. The answer is never in your front-end code. Store secrets in secure server-side environment variables, such as convex environment variables, or your deployment platform's environment settings. The browser should never receive your private API keys. Following this rule protects both your application and your AI service account. Before you hit deploy on Vercel, you need one file, vercel.json. It tells Vercel exactly how to build your app, which command to run, which Node.js version to use, where the output lives. Claude Code can generate one for you, but if you don't understand the options, you'll waste hours debugging build failures that could have been avoided with 3 lines of JSON. Let's build the one that never breaks. Here's a vercel.json that always works. Build command pointing to next build. Output directory as next. The install command line is optional. Vercel automatically detects your package manager and runs the install. But if your project has a non-standard setup, including it explicitly acts as a safety net. Claude Code might include it anyway. Now you know why it exists and that it's not essential. In the Vercel dashboard, I create a new project and import the GitHub repo. Before deploying, I fill in 5 environment variables: Clerk secret, Clerk publishable, convex deploy key, OpenAI API key, and Stripe secret. Vercel injects these at build time and runtime, so Next.js picks them up from process.env. Then I hit deploy. Shortly after, the build log turns green. The app is live. I open the Vercel provided domain. The landing page loads. I click sign up, enter an email, and Clerk sends the magic link. I'm in. I upload a PDF test contract. The progress bar fills. I enter a Stripe test card, click Pay, and Stripe confirms. Seconds later, the translated English version appears with a download button. No console errors, no blank screens. Every piece of the stack, authentication, database, AI translation, payments, is alive. This is what shipping feels like. Before you call it shipped, run through this checklist. Sign up works, JWT appears, Convex creates the user, Stripe processes payment, and the translated file is downloadable. Every checkmark confirms that the full user journey runs end-to-end. Miss one, and you've shipped a demo that breaks for real users. In the next lesson, we'll continue expanding our Claude Code workflow by integrating Git and GitHub. You'll learn how to manage repositories, create branches, commit changes, and streamline collaboration directly from the command line. If you're following the series in order, this naturally builds on everything you've completed so far. Staring at a vercel build log that just says, "Error, cannot find module convex" is soul-crushing. The fastest debug cycle is to copy the entire build log, paste it into a fresh Claude Code window, and ask exactly, "This build failed. What should I fix?" Claude scans the log, identifies missing dependencies or misconfigurations, and suggests the precise code change. In 30 seconds, you go from a cryptic error to a working deploy. That's the power of having an AI pair programmer that can read logs. When it's all wired up, this is what your architecture looks like. Vercel hosts the front end and API routes. Next.js serves pages and handles server-side logic. Convex is your real-time database and action runner. Clerk handles authentication. Stripe processes payments. And OpenAI powers the translation. Notice there's no glue code smell. Claude Code worked through each integration step by step, making sure these services actually talk to each other. You own the whole stack now, not just a piece of it. Let's finish with the most important question in this lesson. How do you know your full-stack application is truly working? It's not enough for the homepage to load. A production application is only complete when the entire workflow succeeds from beginning to end. A user can sign in, upload a document, complete payment, trigger the AI translation, and successfully download the finished result. When every step works together without manual intervention, you've built more than a demo. You've built a production-ready application. You started as someone who maybe could build a static page. You now have 3 powerful shippable skills. First, you can scaffold a full-stack application with Next.js, Clerk, Convex, Stripe, and Vercel. And you know how to use Claude Code to wire them together without spending days on config. Second, you understand the exact auth and database wiring that prevents sign-in errors. JWT templates, issuer URLs, and Convex auth config are no longer black magic. Third, you know the deployment config that stops silent vercel failures. That vercel.json with install command saves hours. That's not theory. That's a project you built, tested, and can show. Don't let this project sit on your local machine. Push the repo to GitHub. Write a clean README that explains the architecture, deploy it live on Vercel, and drop that link right onto your resume. This is your proof that you deliver whole apps, not just fragments. You've built a production-ready application from end to end. The next step is learning how professional developers manage that code over time. In the next lesson, we'll integrate Git and GitHub with Claude Code so you can create repositories, work safely with branches, manage commits, and collaborate without losing your work. These version control skills are just as important as writing the application itself because they're part of every professional development workflow. If you're following this series from the beginning, I'll see you in the next lesson. Remember, careers aren't built by watching videos. They're built by applying what you learn. Pick one thing from today's lesson, build it, document it, and share it. That's how you get hired. Thanks for watching Hired in IT, where we're turning IT knowledge into career opportunities.